Hello, this is Chapter 5, Section 6, Part 1 of the notes for and the situation is if it has, here we need integer, if it has integer coefficients. What we're going to do depends on the polynomials being full of integers. Then every rational of f has the following form. Let's start p over q, we're going to be making fractions, and a factor of the constant term. The constant term is a naught, a0, divided by a factor of the leading coefficient. The leading coefficient is an. There you go. Of course, like most math theorems, they don't make a whole lot of sense until you have a chance to do an example. So we're going to move on to a quick example. Example 1. Find all the real zeros of f of x equals x to the third minus 4x squared minus 7x plus 10. It says list the possible rational zeros. The leading coefficient is, the answer to this is 1 because of the invisible 1 in front of x to the third. And the constant term is 10. And that comes from the constant term there. So the possible rational zeros are, now every time you're making possible rational zeros, you're making a fraction. So probably before you worry about the numbers too much, you should draw fraction bars. We need on top the factors of 10. So 1 is a factor of 10, 2 is a factor of 10, 5 is a factor of 10, 10 is a factor of 10. And on the denominator, we need the factors of 1. Now, the good news is that when the leading coefficient is 1, there's not a whole lot to do there, but positive and negative versions of each of them. That means, according to the rational zero theorem, and this will be a big deal for the rest of the unit, you have 1, 2, 3, 4, 5, 6, 7, 8 different numbers to try. Positive 1, negative 1. Positive 2, negative 2. Positive 5, negative 5. Positive 10, negative 10. That's kind of annoying. The next part says test these zeros using synthetic division. It says test x equals. I find it particularly unhelpful that you're supposed to guess which one of those 8 works. The good news is that 1 works, and 1 is always the nicest number to try first. So we're going to use 1. 1 goes in the box. We have the usual synthetic substitution business. That is the world's worst arrow. Let me try again. 1. It goes up, multiplied by 1. Boom. Added together, negative 3. Goes up, multiplied by 1. Negative 3. Added together, negative 10. Goes up, multiplied by 1, negative 10. Added together, 0. So, we know, since it ends in 0, this is a big deal, we know that 1 is a 0. The number you test, if you get 0 left over, that means that 1 is a 0. That also means that we can factor it nicely. First of all, x minus 1 is a factor, and we get to use the leftover numbers for what's left. We have x squared minus 3x minus 10. We can factor that pretty quickly. X minus 1, x minus 5, x plus 2. So with that, we know the zeros, right? One of the zeros is 1. That comes from here. One of the zeros is 5. That comes from here. And one of the zeros is negative 2. That comes from here. Using the rational zero theorem, we factor